All right, so 6.6 notes. That's what we're starting with today. Right? Okay, sorry. You guys were saying stuff. I thought I was on the wrong thing or something. All right, so 6.6, we've been working with polynomials, and today we're going to talk about the remainder and factor theorems. So, our goal today is to evaluate functions by using synthetic substitution and to determine whether a binomial is a factor of a polynomial and factor completely. So today is super important to make sure that we really understand this. So make sure you're asking questions because it leads into what we do in 6.7 and 6.8 as well. Okay. So it's kind of like a mini idea, and then we are going to build on it over the next couple lessons as well. Okay. But we have time because, like I said, today we're focusing on the notes. You guys will have plenty of time to work. Next week when I see you, the first day will be review, and then the day after that will be the quiz over it. Okay, so we got plenty of time to practice this and make sure we're understanding it before we take our next quiz. All right, so the first thing that we're going to do is, what type of problem is this if we had this trinomial times this binomial but to the negative first power? What's that negative first power tell us? That we're dividing it. It actually becomes part of the denominator, and if you have this in the numerator and that in the denominator, then we're taking this polynomial divided by x minus 3. So we have two different ways to do this. We have our long division, and then we have synthetic division. So these are review. So go ahead and let's set up our long division. Double check that we have this in order, so the degree goes 2, 1, 0. So that looks good. I don't need any placeholders. I'm dividing by x minus 3, so that goes on the outside. Okay. The synthetic division, same idea. I only have to write the coefficients here, so the first one is a negative 3, negative 3. 2, 1, 0, so the next one's 5. And 4, I don't need any placeholders. What number goes in that box? A positive 3, because remember this shows up as negative 3 here, it shows up opposite in the box. And that's because of that whole subtracting part that is on our synthetic division that we now are turning it into addition. So we set these both up. I'm going to go ahead and I'm going to freeze the screen and I'm going to work it out, and I want you to work it out as well because this is review and you guys need to make sure you know how to do both long division and synthetic division. Okay? Okay, so either way you do it, long division or synthetic division, we get negative 3x minus 4 plus negative 8 over x minus 3. Okay. You could have also written this as minus 8 over x minus 3 and had the subtraction sign, but always make sure that that remainder is another term in there. So I've noticed some people there's no plus sign in between. Okay, it should be another term, so you should be adding it. If you don't put it there, that means you're multiplying by it, and that's not correct. Okay. The next problem it says is given f of x is equal to negative 3x squared plus 5x plus 4. Evaluate f of 3. So what are we going to do to evaluate f of 3 here? Plug in the 3. So all we're going to do is we're going to take f of 3. The x is replaced by 3. So that means every x has to be replaced. So I'm going to put parentheses around just where the x is, and I'm going to replace it with 3. Now be careful, because many people will not put parentheses in the right spot, and if it's a negative, then that's a much bigger deal. But this is what it should look like. So let's go ahead, use our calculator, and figure out what f of 3 is. If you did not already trade a phone for a calculator, you probably want to do so now. So we're getting negative 8. Anyone notice anything? It was the remainder. So let's take a look at what we actually are looking at then. This equation is what we started with, both here and technically here and there. Okay. That that 3 that we plugged in not only showed up there. Oh, you guys can't see that. You can't see what I highlighted. There we go. Okay, that 3 that we plugged in was the same 3 from the box, which was because we divided by x minus 3 is what we divided by x minus 3. Huh. Weird. Coincidence? No. Okay. That is the remainder theorem. The remainder theorem says that if we were to plug in 3, we can figure out what the remainder is in the end. Okay. Now what happens if there's not a remainder? Like, if I did 8 divided by 4, my answer is what? 2. Why? Well, there's no remainder. What does that mean? What do you know about 4 and 2 compared to 8? What are 2 and 4 compared to 8? Factors? Ever heard that word? Yes. Well, this is way back, right? I mean, you guys are giggling because you're like, wait a minute, why? I learned that way long ago. But, right, 8 has factors. What are 8's factors? 4 and 2. What else? 8 and 1. Right? I think that's it. 12 has factors. What are the factors of 12? 4 and 3 would be a pair. 6 and 2 are a pair. 12 and 1 are a pair. Those are pairs, but each one individually is a factor. And what it means to be a factor is what? What does it mean to be a factor? How do you guys come up with those numbers? It goes into it evenly. So you can divide by that number. It goes into it evenly because there's no remainder. Right? If I did 12 divided by 5, what happens? I'm going to have a decimal, which it means I have a remainder, which is why 5 is not a factor of 12. Are you with me? Now, I'm taking you way back to probably like 6th grade or something. Maybe even before that, I don't know. But somewhere around then. Long time ago. But it's stuff that you guys know, but you don't even realize you know it anymore because it's not something you talk about usually. Right? Okay, so let's look at this. The remainder theorem, what it says is that if we have a polynomial, that's all it says is a polynomial, okay, divided by x minus a, so that binomial. So we take polynomial and divide by this. That has a remainder that is equal to, so remainder of p of a. So I'm going to kind of explain this to you. You may need to add some more notes to your notes, depending on how I'm explaining this to you. Okay? This is a polynomial. So if you don't know that p of x means a polynomial, you might want to write that down underneath it. A polynomial. Okay? Divided by, this is a binomial. X minus, a is just a number. So if you want to write that on top of it, like x minus a number, example would be like x minus 3, like what we were doing up here. Right there. Okay? So x plus or minus a number. Okay? If I do a polynomial divided by x minus a number or x plus a number, that's going to have a remainder that would be the same thing as if I took that number that shows up, make it opposite, plug it into the polynomial. If I plug that in, it'll tell me what the remainder is going to be. Okay? Same thing what I did up here. I took a polynomial, I divided by x minus 3. Now, if I didn't do the division, I could have said, okay, let me plug in 3, like what I did here, f of 3, and I found that my answer was negative 8. Then without even doing the division, I know my remainder is negative 8. And you're like, well, why is that necessary? Why do I care what my remainder is? Because that tells us whether something is or is not a factor. Okay? If it has a remainder of 0, that means it's a factor. Just like if I do 12 divided by 5, I'm going to have a remainder, so 5 is not a factor. And I know that. But there's no easy calculator of typing in the polynomial divided by a binomial to say, is it a decimal or is it a whole number? Is it a polynomial or does it have a remainder? There's no easy way to do that other than actually doing division here. So that would be your easy way. If it has a remainder, it's not a factor. The remainder is 0, then it's a factor, and we know that. Okay. So that means that if you don't like to plug stuff in this way, but let's say you were asked to find f of 3, you could use a process called synthetic substitution and figure out what your value is. Okay? So this says that you can use division. Oh, sorry. So you can use division to evaluate a function. So what does this mean? This means that if you take a polynomial divided by x minus a, it equals p of a. Meaning that you can set this up, okay, the division problem. A would go in the box, right? You would have your coefficients all across the top. You bring the first number down, blah, 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 blah. And right here would be your answer to if you plugged in A to P. Okay, I know it's a little confusing because we're using all symbols here, so we're going to go through some examples too, so don't stress about that. Alright, so then what does the factor theorem say? We've mentioned this one already too, and this is just says that if you don't have a remainder, or your remainder is 0, then it means it's a factor. That's what the factor theorem says. So it says the binomial x minus r, I don't know why we do use a different variable on this one, but could write x minus a, it doesn't matter. This binomial, x minus a number or x plus a number, is a factor of the polynomial p of x if and only if when you plug in that our value, you'll get 0. Now the reason is because this is the remainder. If you get a remainder of 0, it means it's a factor. Now there's many ways you can find a remainder. You can choose to divide, or if you plug in whatever this number is, the opposite of how that number shows up, plug it into the polynomial, you'll get a value that will tell you what the remainder is. Okay. All right, so are we ready for some examples? Because I know I'm just blowing your mind right now. All right, so use synthetic substitution to evaluate a function. So we're going to write out what problem is given. So we're given that f of x is equal to 3x to the 4th power minus 2x to the 3rd power plus 5x plus 2. And we're asked to find f of 4. So there's our problem. That's what's given to us on our homework. Something like that. So then what I'm thinking in my head is, okay, I could plug in 4, but it says to use synthetic substitution. So that means I want to look for the remainder. So I'm going to do synthetic division, but I'm looking at the remainder to be my answer. Okay? So we're looking for the remainder as if we did f of x, so this polynomial, divided by, since we want to plug in 4, we're going to divide by x minus 4. Now the cool thing about this is if I wasn't asked to use synthetic substitution, raise your hand if you know how to plug in 4 to this problem. Raise your hand. How many of you guys know how to plug in 4 and figure out what f of 4 is? I think most of you. Okay, good. Because it says you have to solve it using synthetic substitution. So you're going to have to show your work to get your points. But on a quiz, you have a way that you guys have been doing much longer that you could check f of 4 and make sure you're getting the right answer. Right? So you have two options here of how you can check it. So I'll show you how you can check it in a minute. But we're using synthetic substitution, so we're going to have something in the box. The long line, look for that remainder. What number goes in this box? Positive 4. It shows up the same as if we were going to plug it in, but it comes from the binomial x minus 4. X minus 4 told you to make it opposite. Okay. So our coefficients, double check that we go in order. 4, 3, 2, 1. Wait a minute. No, that wasn't right. 4, 3, what's this degree?
2.
It's supposed to be 2, but it's 1. So that means I'm missing the 2. So maybe even you want to write in here plus 0x squared. So 4, 3, 2, 1, 0. Now that looks better. Okay, a lot of people missed that on their quiz. Last week was a placeholder and it messed them up. Okay, so here across the top we have 3, negative 2, 0, 5, 2. 4, 3, 2, 1, 0. Okay, so I double checked everything. Do synthetic substitution or synthetic division. Doesn't matter what way you look at it right now. It's the same thing. Bring down the 3. Multiply by the box. 3 times 4 is 12. Add them up. Negative 2 and 12 is 10. Multiply by the box, you get 40. Add them up. You get 40. Multiply by the box, 160. Add them up, 165. Multiply by the box. I don't know what that is, so I'm going to use a calculator. 660. Add them up, 662. Now remember, always double check with your calculator if you have time, because it's better to be safe than sorry. So you brought down the 3, multiplied by the 4. Added that, to negative 2. Got 10 multiplied by 4. Got 40. Added 0 to that, stayed with 40. Multiplied by the 4 in the box, got 160. Added 5 to that, got 165. Times that by 4, got 660. Added 2 to that, got 662. So I can easily use my calculator in previous answers to just go through that algorithm where you multiply by the box, add them up. Multiply by the box, add them up. Okay? What is your answer here? 662. Okay? So f of 4 equals 662. Now, let's say I forgot that 0 right there and I got a different answer. And this next part is important because many people tend to do that. So what I would do in my next step, as long as I have extra time, is I would go through and say, okay, I know how to find f of 4. And a lot of people also accidentally put a negative 4 here in the box, and that throws them off. Okay? The setup is the hardest part over here. You guys can add and multiply, no big deal. You guys have calculators, so you can do that. But I know f of 4 is supposed to be 3 times 4 to the 4th power minus 2 times 4 to the 3rd power plus 5 times 4 plus 2. And I can do that on my calculator because I'm a calculator expert and have been using it for a while now. So 3 times 4 to the power of 4 minus 2 times 4 to the power of 3 plus 5 times 4 plus 2. And I'm supposed to get 662. So that's my way of checking it. Cool, I did it right. However, if I'm not getting the same answer both ways, I need to go back and say, first off, was I missing a 0, a placeholder? More than likely, you probably are, because a lot of times they're hidden in there and people miss them. So double check that first. Then, maybe you put the wrong number in here. Maybe you put negative 4 instead of 4. Okay, so always use that as your way to double check, especially on a quiz or a test. Now that we have tests in here, we don't have quizzes. Okay. Can I go ahead and flip this over? All right. It says, given a polynomial and one of its factors, find the remaining factors. Okay. This says it's one of its factors. Oh, sorry. There you go. That's better. Okay. So part of what's given to us, too, is also that x to the 3rd minus 7x squared plus 7x plus 15. That's the polynomial. And they give us x minus 5. Okay, so that's the problem right there. It says, given a polynomial and one of its factors, find the remaining factors. Then write the polynomial in factored form. Okay. Based on what it says, this is one of its factors. X minus 5 is a factor. What does that mean? It has a remainder of 0. If I do this divided by that, I have to get a remainder of 0. Well, that right there tells you that when you go to do your division, make sure you have a remainder of 0 because it told you it's one of the factors. And if you don't at that time have a remainder of 0, then something went wrong. Does that make sense? Okay, so that's the first thing we're going to do is divide that one out. Okay? Because this is a factor. I'm just going to make a little note of that. Okay, that's a factor. So when I go to do my division, double check that we're all in order. This is degree 3, 2, 1, 0. I don't need any placeholders there. So there's 1, negative 7, positive 7, 15. What goes in the box? Positive 5. Okay. Now I'm going to write it in already because what do I know about my solution? The 0. The remainder has to be 0. Okay? I'm going to hope that I get 0, but I'm going to write that in because that's going to be my red flag. If I don't have 0 there, then something went wrong because it told me that that's a factor. All right, so bring down the 1. Multiply by the box, you get 5. Negative 7 and 5 makes negative 2. Multiply by the box, negative 2 times 5 is negative 10. Add them up, 7 and negative 10 is negative 3. Multiply by the box, negative 3 times 5 is negative 15. Add them up. I do get 0, so I'm confident that I did my division part correctly. Are we okay so far? Give me a 1 to 5. I'm following you. I totally get why that's a factor and how that shows that it's a factor. Okay, awesome. All right, so we'll put a little side note here. Must be 0 because it said it was a factor. Okay. Okay, so now we're going to go back to when we were doing division, okay? Because what we're trying to do is we're trying to take this polynomial and we're trying to factor it. We don't want to change the value of it, we just want to factor it. So what we already divided out was the x minus 5. And what we had left when we factored that out was, this is the remainder, degree 0, 1, 2. So x squared minus 2x minus 3. That's what's left. Now before, when we were doing our division, that's why I made you check your solutions. Because this has to be equivalent to what we started with. Remember when I made you multiply to verify that you divided correctly? Okay? We are going to continue factoring it. This is your setup, but we have to continue factoring it because it says that we need it in complete factored form. Okay? That's not in complete factored form. We have a factor times, this is a quadratic, which probably can be factored further. So we're going to rewrite it. We had the x minus 5. Let's try to factor this trinomial into 2 binomials. Okay? So we're just unfoiling it. Your first times your first has to multiply to x squared. So what's your first times your first have to be? X times x. Okay? Your last times your last has to multiply to 3. Okay? What numbers multiply to 3? 1 and 3. We don't have much of a choice there. However, it is a negative 3, so one of them has to be positive and one's negative. So trial and error here, give a plus and give a minus. Try your outside and your inside. Your outside would be negative 3x. Your inside would be positive 1x. Does that make negative 2x? Negative 3x plus 1x, is that negative 2x? Yes. Okay, cool. So I guessed right on my first time. So I have a minus 3, the plus 1. Now that is in complete factored form. Okay, so how can I check this then? If I want to check this, I need to make sure that my factored form equals my standard form. That's my factored form. Okay. What I originally started with, this up here, was my standard form. I want to make sure that those two are equivalent. The standard form and factored form, I didn't change the value of anything. I just changed the way it looked. So I can double check that by multiplying this back out and making sure that it is actually accurate. Now, let me take you back. If I multiplied 3 numbers together, 2 times 3 times 4, how would I multiply 3 numbers together? 2 times 3 is 6 times 4 is. So pick 2 of them, multiply them together, and then take that and multiply by the next one. Okay? So what I'm going to do is I'm going to rewrite this. I'm going to take the first two. I'm going to multiply those together. I don't care here if you use box method or if you use the seashell method, okay, or just FOIL, because that's what it is here. But I'm going to have that answer, and I'm still going to have to multiply it by the x minus 3. So I like to just distribute, so FOIL basically here. So my first times my first is x times x is x squared. So far so good. My outside is x times 1, which is 1x. My inside, minus 5x. And my last, negative 5 times 1 is minus 5. Now, I do have some like terms there, so I'm going to simplify it a little bit. X squared minus 4x minus 5 times that x minus 3 still. Are you with me? Let's make sure to get that down, okay? Now, I have two numbers to multiply together. Trinomial times a binomial. And when I do that, here again, you can choose to use the box method or you can distribute, doesn't matter. I'm going to distribute my x to all those terms. And then I'll go back and distribute the negative 3 to all three terms. So I have x to the third minus 4x squared minus 5x. When I distribute all those x's through, distribute the negative 3 through, negative 3x squared plus 12x plus 15. And now combine any like terms. X cubed doesn't have anything like it. X squared and x squared, that's minus 7x squared. Negative 5x and 12x is a positive 7x. And the 15 is a lonely term that doesn't have any friends. There we go. Did our factored form match our standard form? Were they equivalent? Yes, they were. And so that's it. Our factored form matched our standard form. That means that this was correct. This is the correct factored form up here to what we started with. Okay, so let's look at what we're expected to do on the assignment then. On the assignment, it says, use synthetic substitution. If you just plug in negative 5, you will not get your points here. If you plug in 2, you do not get your points here. You have to actually set up synthetic substitution because that's what it says in the directions. Every year, people have numbers for these with absolutely no work shown, and you get no points. Okay, no work, no credit. So 1, 2, 3, and 4, synthetic substitution for all of those. You have 2 different values on each one. Double check it by plugging it in, how you know how to do, but make sure you're set it up correctly. On the back side, it says, given a polynomial and one of its factors, find the remaining factors of the polynomial and write the original polynomial in factored form. Then check your answer. That's exactly what we did on the back. It gave you one of its factors. Divide it out. The remainder should be what? 0, because it's a factor. Okay? Then you'll know you'll have the x plus 2 times whatever is left, and then try to keep factoring that down again. Then check by multiplying like we did. That's for 5, 6, 7, and 8. 9 and 10 are to explain the remainder theorem and the factor theorem using your own words. That's why I told you that when we were taking those notes, jot down what you know it means as we were discussing it. And then number 11 is a story problem. It is a fake story problem where you have to use synthetic substitution. Meaning, if you look at the polynomial that's given, and then it gives you 2 different t values, and it's asking you to use synthetic substitution, you can probably figure out what to do without even reading the scenario. Okay, so it's a fake story problem. You don't have to sit there and really be scared because it's a story problem. All right?